Hello my dear students, welcome to the chemistry classes. Let us discuss about the continued part of the chapter D and F block elements. In the previous sessions of this chapter, we have discussed about the some of the concepts of this chapter, like it means what is the classification of the periodic table and where we can find the D and F block elements. Both D and F block elements are coming under the classification of the periodic table. It means the periodic table can be classified into totally 4 different blocks: S block elements, P block elements, D block elements and F block elements. S block elements are nothing but the outermost electron will enter into the S atomic orbital. Those are called as the S block element, and the outermost electron or upcoming electron will enter into the P atomic orbital, where outermost P atomic orbital. Those are called as the P block element, and another one is the D block elements. D block elements are nothing but the upcoming electron will enter into the outermost P atomic orbital. Those are called as outermost D atomic orbital. Those are called as the D block element, or those can be classified under the categorized under the D block elements. Another one is the F block elements. F block elements are nothing but the upcoming electron will enter into the outermost F atomic orbital. Those are called as the F block elements. Like this, we can classify all the elements into the 4 different blocks based upon the electronic configuration of each element. And next one, especially we are going to discuss about we are discussing about the D block elements and F block elements. Now we are going to discuss about the continued part of the chapter D and F block element. In the previous sessions of this chapter, we have discussed about the classification of the D atomic orbital or D block elements. These D block elements can be classified into 4 different series. First one is the 3D series, 4D series, 5D series and 6D series of elements. There are totally 4 series of D block elements. Next, also we have discussed about some of the periodic trends in the D block elements. Periodic trends means periodic in the periodic property in the periodic table, as we have studied in the general properties, like that we are going to study about the elements of the D block elements in detail. There are totally general properties or general trends in the periodic properties of D block elements. In that, we have discussed about the more number of properties. First one is the atomic size. First one is first we have studied the atomic size. Second one, ionization. Second one, we have studied the ionization enthalpy. Third one is the oxidation state of the elements. Oxidation state of the elements. It means 3D series of elements will exhibit the different oxidation states. And fourth one is the standard electrode potential. This can be abbreviated as SEP. SEP is nothing but the standard electrode potential of each element. And another one is the magnetic properties. Magnetic properties of the D block elements are nothing but the metals. It means these metals will exhibit the different metallic property: paramagnetic, diamagnetic. Another one is the ferromagnetic property. These properties exhibited by the metallic elements. The 3D D series of elements are almost the metallic elements. These will exhibit the metallic property. This metallic property, magnetic property. This magnetic property also we can study in we have studied in the previous class. And next, in this class we are going to discuss about the next point, that is formation of colored complex. Formation of colored complex. And next one, Formation of complex compounds. Formation of complex compounds. 8th property. Catalytic properties. 9th one, alloy. Alloy formation, and another one is the formation of interstitial compounds. Formation of interstitial compounds. These are the general trends or properties we can found in the periodic table of the D block elements. Especially for the D block element, these are the properties we can study in the periodic table. For the D atomic orbital. For the D atomic orbital. In the previous session, we have discussed about the atomic size, ionization enthalpy, oxidation state, standard electrode potential. Next, magnetic properties also we have studied, and next we are going to study about the continued part of the general trends or general properties in the D block elements. And first one is here, formation of colored complex, formation of colored compounds. It means more elements of the D block elements will involve in the formation of the colored, or they will exhibit the different colors. More number of D block elements or D elements will exhibit the color. They will exhibit different color. It means scandium, titanium, vanadium, manganese, iron, like this all the elements will exhibit the different color. This property is due to the presence of unpaired electrons. Presence of unpaired electrons in the valence shell. It means valence shell is nothing but the outermost shell of the D atomic orbital. In the outermost shell, there are unpaired electrons are present. Due to the presence of these unpaired electrons, these D elements or D block elements will exhibit the different colors. And another one is the splitting of degenerate d orbitals. Degenerate d orbitals under the influence of anions or ligands. This point is very important. It means the splitting of degenerate d orbitals under the influence of anions or ligands. It means degenerate d orbital means degenerate means equal energy. It means in the D series of element we can observe the totally 5 orbitals. We can observe the totally 5 orbitals in the D. It means in the S atomic orbital we can observe only one orbital. In the P orbital we can observe the 3 atomic orbitals. This is S atomic orbital, P atomic orbital. This is about the D atomic orbital. D atomic orbital having the totally 5 orbitals. It means dxy, dyz, dxz, dx square minus y square, dz square. Totally 5 atomic orbitals we can find in the d atomic orbital. These are all the degenerate, means all are equal in energy. It means equal energy atomic orbitals are nothing but the degenerate d atomic orbital. Under the influence of anion or ligand, anion or ligand means during the formation of complex. During formation of complex, the anions or ligands will approach towards the metallic ion. At that time, these degenerate or these equal energy atomic orbital undergo splitting with each other. These atomic orbitals undergo splitting into the two different types of atomic orbital, T2g and Eg type of atomic orbital. T2g atomic orbitals are nothing but the dxy, dyz, dxz atomic orbitals are converted into T2g atomic orbital, and another one is the d x square minus y square, dz square atomic orbitals are lower energy atomic orbital under the influence of anions or ligand. Or ligands are nothing but these are the substances which can donate the lone pair of electron during the formation of the complex or any compound. During the formation of complex, these ligands or anions approach towards the metallic ion. At that time, the degenerate d orbital undergo splitting with each other, like that T2g and Eg type of atomic orbital, and they forming the different types of atomic orbital. Due to this reason, the electrons from lower energy electrons will jump into the higher energy atomic orbital by gaining energy. This due to the excitation, they will exhibit the different color in the visible region. It means whenever they will gain the energy, they undergo excitation and they will move on to the higher energy level. During the moment of moving towards the higher energy level, they will absorb some amount of light energy in the visible region. Visible region means that is visible light. Among these, the electrons will absorb any one of this color and they will exhibit the different color. Due to this reason, they will exhibit different colors. That is the property formation of colored complex. It means due to this reason, they will form the colored complex. During the formation of complex, they will exhibit the different colors due to the absorption of light while jumping from lower energy to the higher energy during the excitation. Whenever they absorb the light, they will undergo excitation and they will jump from lower energy to the higher energy. During jumping, they will absorb some amount of energy of the visible radiation. They can exhibit the respective color of the element. This is about the color of the formation of colored or colored complex formation. And next property, formation of complex compounds. Complex compounds are nothing but these are the compounds. These are not simple compounds. These are the complex compounds. These are complex in nature. For example, K4 Fe CN6. This is a complex compound. Another one, Ni CN4 2 minus. This is also one of the complex. And next, NaCl. This is not a complex. This is a simple salt. It means whenever it undergo ionization, it can be converted into Na plus and Cl minus ion. This is a simple salt, but this is a complex salt. It means whenever this is undergo ionization, it will form the Fe CN6 4 minus plus 4 K K plus. Like this, it can be converted into different ion. This is a complex ion. This is a simple ion. These are the simple ion. This is a complex ion. Hence, these are called as the complex compound. These are the simple compound. Fine. This is a simple salt. This is a complex salt. Like this formation of complex salt, there will be a involvement of the metallic ion. It means 3D series of element. It means Fe is a 3D series of element. This is a D block element. Nickel also D block element. These can be involved in the formation of the complex. This is due to the some of the reasons. These complexes are forming due to the some of the reasons. First one is the availability of vacant d orbitals in the valence shell. Availability of vacant d orbitals in the valence shell during the bond formation. During the bond formation. It means during the bond formation there is a vacant d orbitals are available. Hence the formation of complex compounds will be takes place. And another one, smaller size of metallic ions. Smaller size of metallic ion. This is also one of the reason. Due to these reasons, the complex compounds will be formed. It means the availability of vacant d orbitals in the valence shell. It means in the valence shell there will be a vacant d orbitals are available during the formation of bond. During the formation of a bond, either this may be metallic bond or this may be a covalent bond. During this formation of bond, there will be a vacant d orbitals are available. Hence, the complex compounds will be formed. Another one is the smaller size of metallic ion. Smaller size of metallic ion, also there will be a unpaired electrons are present in the outermost shell. Hence, due to this reason, the complex compounds will be formed. And next one is the catalytic properties. Catalytic property. This is also one of the most important property. Catalytic property. Before that, we can solve one example for the formation of complex compounds. Here we have taken NiCN6 2 minus. This is a complex. This complex we have taken here. Nickel is the one of the 3D series of element. Nickel is also one of the 3D series of element. Its atomic number 28. Its atomic number is 28. Nickel, and its electronic configuration Ar 3D8 4s2 is the electronic configuration of the nickel. Next, whenever this nickel undergo excitation, it will lose the electron and is undergo +2 oxidation state. This is the oxidation state of the nickel, and then the electronic configuration becomes Ar 3D8 4s0. This is the excited state electronic configuration of the nickel. It means it is undergo oxidation and the electronic configuration of nickel becomes the Ar3D8 4s2. It means the outermost 4s2 electron, lower energy electrons will undergo ionization. At the time there will be a 3D8 is the outer valence shell electronic configuration for the nickel. Next, we can allot the electrons in the 3D series, right? 3D 1, 2, 3, 4, The electron filling mechanism is like this, right? This is the nickel, right? Next, this is the electronic configuration of the nickel, and 4s is completely 0. This is completely vacant in nature. Next, this is the ligand. Ligand means the substance which can donate the lone pair of electron to the central metal atom, right? It means whenever this ligand approaches the nickel atom, whenever this ligand approaches the nickel atom, at that time, due to the strong ligand, the electron from d z square atomic orbital migrated towards the dx square minus y square. At that time, the electronic configuration becomes this is the electronic configuration after the excitation, after the approaching of ligand. Like this, the ligands are approaching towards the central metal atom. At that time, due to the action of this ligand, the electrons are undergo the electronic configuration undergo alteration in the atomic orbital, and they form the different types of molecular orbital. And then here there will be a one vacant place is available. Then this vacant place is involved in the bond formation. This is the method of bond formation which can be take place in the D series of elements. Like this, the bond formation will be take place. And next one, catalytic properties. Next property is catalytic property. Catalytic property is nothing but in the previous chapter surface chemistry we have studied about the catalysis and catalyst. What is the meaning of catalyst? It means the substance which can alters the rate or velocity of the reaction, and it will provide the surface for the reaction. Surface for the reaction. It will provide the surface for the reaction. The catalyst will provide the surface for the reaction. It means most of the D block elements will act as a catalyst. It means they are having the large surface area. It means they are having a large surface area for the reaction. They will provide the large surface area for this reaction. Hence, these can be considered. These can be act as a catalyst, or they can exhibit the catalytic property. They are having the vacant d orbitals in the. They are having the vacant d orbitals in the valence shell. They are having the vacant d orbital in the valence shell, and they will provide the large surface area for the reaction. Hence, these d block elements are act as a catalytic in nature. These can be called as a these can exhibit the catalytic property in the nature of these can considered as a catalyst in the or catalytic in nature. It means their properties they will exhibit the common catalytic property due to the presence of large surface area for. They will provide the large surface area for the reaction, and then is the vacant d orbitals in the valence shell. And next one, formation of interstitial compounds. Next property, formation of interstitial compound. Interstitial compounds are nothing but these are the intermediate compounds. Interstitial compounds are nothing but the intermediate compounds. Intermediate compounds are nothing but these neither ions nor the complex. These are neither ions, or covalent compounds. These are neither ions nor covalent compounds. It means intermediate or interstitial compounds are nothing but these are not ionic in nature and also not covalent in nature. This type of compounds are called as the interstitial compounds. It means by the addition of hydrogen, carbon, nitrogen, these d block elements will form the interstitial compounds. It means TiH4. By the addition of hydrogen to the titanium, this titanium element can be converted into the interstitial compound. Another one is the MnN4. Manganese tetranitride. This is also one of the interstitial compounds. These are nothing but these neither ions nor covalent compounds. It means by the addition of hydrogen, carbon, nitrogen, like this element, these elements can be converted into the interstitial compound. This is another property of another general periodic property of the d block elements. And another one is the last property itself is the alloy formation. Last property itself is the alloy formation. It means the sum of the compounds. For example, steel. Steel is also one of the alloy. It means to prevent the corrosion, we can apply the alloys on the some of the metallic surfaces. Those are called as the alloys. These alloys can be formed by the help of that D series of element. Either there may be iron, or there may be titanium, or there may be a copper, or there may be some elements. By using these elements, we can form the alloys. These alloys, for example, stainless steel. This may be a tungsten steel. Stainless steel nothing but the iron plus chromium. This is tungsten steel and nothing but the iron plus tungsten. Like this, the D block elements combined with the another material. It means the solids are mixed with the another solid. They are forming the solid solutions. These are called as the alloys. These alloys are formed by the help of the D series of element. It means the solid metallic. It means one of the solid metal combined with the another solid metal or another solid. This type of solutions are called as the alloys. These alloys can be prepared by using the D block elements. These are also one of the property of the general periodic property of the D block elements. These are some of the periodic properties of the D block elements. First one is the atomic size or ionic size. Atomic size, it means the atomic size from left to the right, it should be going to decrease. But in the D series of element, there will be a slight change in the atomic radius. It means initially it is going to decrease, and at the middle it remains constant, and at the final it is going to increase. There is a slight change in the atomic size of the D series of element. Another one is the ionization enthalpy. Ionization enthalpy nothing but whenever the element undergo ionization, there will be a slight change in the enthalpy. That is called as the ionization enthalpy. It means first ionization enthalpy is more, second ionization enthalpy is little bit less. Like this, the ionization enthalpy going to change for every element. And next one is the oxidation state. All the elements will exhibit the different oxidation state, and minimum oxidation state is the +1 and maximum oxidation state is the +7. These In between +1 to +7 there will be a different oxidation state exhibited by the elements of the D series, 3D series of elements. And next one is the standard electrode potential. This is about the standard electrode potential means all the some of the metallic elements will exhibit the electrode. They can be act as the electrode. During that electrode there will be a potential will be generated, that is called as the standard electrode potential. Next one is the magnetic property. We have calculated some of the example magnetic property for the some elements. And another one is the formation of colored complex. This is due to the presence of unpaired electrons and availability of the vacant d orbital in the outermost shell. And next one, formation of the complex compound. This is also same reason, availability of vacant d orbital in the outermost shell. Another one is the presence of unpaired electrons in the outermost shell. Next, catalytic property. Catalytic property are nothing but it means most of the d elements will exhibit the catalytic property, or these can be act as a catalyst due to the presence of large surface area for the reaction, or they will provide the large surface area for the reaction. Another one is the they are having the unpaired electrons in the outermost shell, and also they are smaller in size. Due to this reason they can be act as a catalyst in nature. The next one, alloy formation. Another one is the formation of interstitial compound. It means by adding the some of the impurities like hydrogen, carbon, nitrogen, like this atom, by adding like this atom, they can be act as a interstitial compound. Interstitial compounds are intermediate compounds like that. They are neither ion nor covalent compounds. Hence this type of compounds are called as the interstitial or intermediate compound. By adding this type of element, they can be converted into the interstitial compound. And next one, alloy formation. Alloy formations are nothing but these are the solutions which are having the solid in the solid. It means the solid one of the solid solutions or metal solid solution distributed among the other solid solution. This type of solutions are called as the alloys. Example, stainless steel. Iron can be distributed in the chromium. Another one is the tungsten steel, that is iron can be distributed in the tungsten. These are the one of the type of the alloys. These are the some of the periodic trends or periodic properties of the D series of elements. In the upcoming class we are going to discuss about the some of the compounds like K2Cr2O7. Another one is the KMnO4 preparation method. In the next class we are going to discuss.